All right, so these were the last, or these are graphed examples rather, of the proofs that we're going to be using. So the proof again has 3 steps: function value, limit, do they match? Function value, limit, do they match? So for the first one, we're going to start by looking at the first step. Our very first step is, what is the function value? So in this case, obviously the point we're going to be interested in is this point where x is 1. And we're interested in that because the rest of the graph has nothing interesting going on in it. It's continuous, there's no stops, there's no starts, there's nothing along those lines. So for number 1, we're going to be looking at the function value at 1, which the solid dot is at -2. Then we have to look at the limit. Well, I'm looking for the limit as x approaches 2 of f, as x approaches 1. As we're, this is the x value, so as x approaches 1 of f of x. So for this one, I don't have a function, so I can't use substitution. I'm going to have to use left versus right. So if I have the limit as x approaches 1 from the left, I look like I'm going towards this 1 value. So from the left, I'm going towards 1. Then I'm going to do the same thing coming from the right. So the limit as x approaches 1 from the right of f of x. So coming from the right towards that point, I'm also approaching 1. Left and right match, so my overall limit is 1. So step 1 worked, step 2 worked. Now what you guys all should be catching on is that step 3 is not going to work. Step 3, we're comparing part 1 and part 2. So what you're basically trying to prove is that the function value, parentheses there, the function value at 1 needs to equal the limit as x approaches 1 of the function. Well, the function value is -2 and the limit is 1. Are those equal? No, they're not. So then you would say part 3 fails. So they're not continuous because part 3 of our proof fails. So at this point, I would say probably pause the video so that way you could try the next 2 on your own. And when you're done trying those out, come back and I'll go over them as well. All right, so at this point you should have paused it, tried 2 and 3 on your own, and then come back. For number 2, part 1 is always to find the function value at whatever the sticky point is, whatever the crazy point is on the graph. The graph is the same x value as we had in number 1. So I'm looking at the function value at 1. There's no closed circle. So that means the function value at 1 does not exist. If I have a function value that does not exist, that automatically fails the whole thing. I don't have a value. I don't have anything to say that it works. So part 1 fails. And we move on to number 3. Number 3, we've got the same sticky point. So f of 1, in this case, is 0. Our second part is to find the limit as x approaches 1 of the function. And because it's not an equation, I can't use substitution, I'm going to have to use the limit. So the limit as x approaches 1 from the left of f of x equals, from the left, I'm going towards this point. So that's 2. From the right, I'm approaching this point, which is 0. 2 does not equal 0, so the limit does not exist, therefore part 2 fails. All right, so I've got 3 different types of failures that happen when looking at the graph. Now, does every single thing fail for continuity? No, not everything's going to fail for continuity. But these are a lot of examples of where you're going to find different failures. So now we're going to go ahead and try it where you don't have the graph, so you're not going to use left versus right all the time. We might be using some substitution in the next cases. All right, so let's look at number 4. So the first thing we're going to do, it's given us a c value. It said that c is 3. And I want to find the function value at 3. So that's part 1 to proving continuity. So that's 3 times 3 plus 2. 3 times 3 is 9. 9 plus 2 is 11. So my function value at 3 is 11. Then I go on and I say, okay, part 2, the limit as x approaches 3 of f of x equals. Now, is there anything, if I plug in, if I use substitution in this one, am I going to get a 0 over 0? My hope is that you will say no, because what's on the bottom is a 1. So, 3 times x plus 2, it's all over 1, so I can just use substitution again. So my limit is going to be, using substitution, 11. So, that works. That works. Step 3, though, is where you compare step 1 and step 2. Is f of 3 equal to the limit as x approaches 3 of the function? Well, I have 11 and 11, they are equal, so yes, this is continuous. So you would have to write a statement at the bottom saying continuous at x equals 3. And that's your final answer. Alright, so go ahead, pause, try number 5, and then I will go over it with you in just a few minutes. Alright, so at this point you should have tried number 5 on your own, and then come back to talk to me about it. So the first thing you're going to do is realize that they have given you a c value. You're looking at where c is 2. So for part 1, I want the function value at 2. Well, where is my equal to? My equal to is right here. This x is equal to 2, so when x is 2, the function value is 6. Then I go for my limit. Well, when I'm dealing with this limit, this is talking limit from the left and limit for the right. So because this does both at one time, I'm actually talking about my overall limit right now. And I need to plug it into the very first equation. So if I plug in 2, I'm going to end up with 4 minus 4 over 2 minus 2. That gives me a 0 over 0. So this needs to be factored. So really, what I'm looking at is this. I want to plug in x plus 2. I want to plug 2 into x plus 2. So, the limit as x approaches 2 from f of x, you can do left and right if you want to write out those, but because the does not equal covers left and right, it's doing it all at one time, you don't actually have to. So using substitution, the limit as f approaches x, or as, sorry, x approaches 2 of f of x is 4, because that's what 2 plus 2 is. So that works and that works. So step 3, I've got f of 2 equals the limit as x approaches 2 of f of x. Well, is 6 equal to 4? No, it's not, so part 3 fails.